This isn't really an ordinary video. This is basically just what's on my bench right now, exploring this stuff. It's things that are going to appear in future videos, but it's just what is all over my bench at the moment before I tidy it off and start making more videos. So one of the things I'm doing at the moment, at the point of making this video, it's late November. It's time to get some Christmas lighting and stuff ready. So I'm going to be building another Department of Villainy control circuit board. This is based on a PIC microcontroller running a bank of 15 MOSFETs to give animation on a display from a 12 or 24 volt supply. In this case, it's going to be a 12 volt supply. So to build this, I had to order components, and rather annoyingly, one of my favourite terminal block, which is a cut to size version, is out of stock. So I'm giving this stuff a go. Hold on, let's see if it fits. Is it going to fit? Yes, it fits. That's quite good. And it is rising clamp. So maybe this is going to end up being my new standard, because the other one is getting harder to get. The stuff that comes in 36-way strips. So I've got these connectors, and I've got these connectors. Other stuff I bought from CPC, where I bought a lot of this stuff, was cable glands for the controller for the mains, the low voltage, the 12 volt cable going in. And anything else for that particular thing? Anything else for that particular task? Yes, Polyswitch thermal fuses. I got a few different types, partly because I wanted to check them out and test them. Both of these, I believe, are rated 1.85 amps each, and a Polyswitch fuse, PTC fuse, is one that is basically a disc of material that, as its temperature rises, its resistance rises. So if you put it in place of a fuse, it's only suitable for breaking relatively low currents, like a standard glass fuse. But when the current exceeds its trip threshold, it starts heating up, and because it's going high resistance as it heats up, that results in more power dissipation across it, and it results in a sort of thermal runaway, and it suddenly gets very hot, and the current through your fault reduces to a safe level, and then this just sits here limiting the current to safe level while staying hot. So I've got two sizes here. This one may have a faster trip characteristic and may be rated for lower voltage, but either way they're both rated perfectly for the application. These ones are probably the ones I used last year, I think. The other one I got should be down here somewhere, but it's surface mount, so it's tiny. Hold on, let's see if I can find it. Or have I put it somewhere? Maybe I've put it somewhere. Maybe I'll just look at that when I eventually find it as I dig through the other stuff. Yeah, anyway, oh, there it is. They're in tape. These are the surface mount versions, so much smaller, but they've got an interesting construction. Unlike the resistors, which basically have an electrode at each end and then a carbon film across the top, these actually look like a little sandwich with a plate above and below. So if this was the material, it's got an electrode coming down like this, but going to one side, and then the other side it's got like that, just to actually provide a connection to both sides of that material. But I'll probably crack out the microscope and take a closer look at these and see what the construction's like. This came from eBay. This came from a Polish seller. A Polish seller with a whole medley. They sold things like home brew stuff, kits for making huge quantities, basically, of vodka or rum. But one of the other things they sold was rosin. Colophony rosin. So this is the raw pine resin that's used as soldering flux. And interestingly, I've got the soldering iron running at the moment, so you'll see that when I touch it to this, it tends to fume now. I got a big chunk out. I'll look at the biggest chunk here. I noticed it does something interesting when you heat it with a heat gun, but initially I shall touch it with a soldering iron, which is why I have the soldering iron on. And it immediately gives off that classic vapour and that nice piney smell you get from soda. Oh, don't breathe it, it's flux. Well, that's what flux is. It's pine resin. It's surprising to think that's all it really is. But, I mean, you get modified fluxes, but the majority of soldering flux is, in fact, pine resin. I've just dripped this everywhere. Doesn't really matter. Here's the hot air gun. Let's not put my finger in the freshly melted. Oh, it's kind of cured. Watch this. If I zoom down a bit, in fact, and heat this up, you'll see it doesn't just sort of polish the surface, but it actually cracks and fractures. Is this stuff going to crack and fracture? Hold on, I'll turn it around to the other side. The other bit I tried, yeah, you can see the little cracks popping and cracking here and there. but it goes a nice sort of, because it's quite dusty and rough, because it is just broken up solid material, it takes on a nice sort of sheen when you heat it up. I now have a big lump of molten flux in my hand. I'm going to give that thing a go that others have been doing, whereby they're basically, the flux is a small quantity of this in isopropyl alcohol. I could have tried that right now. I'm very tempted to try that right now. Let me try that right now. Actually, you know what? I might try. Hold on. While we're doing this, I might put a little bit of this into the bottle and see if it dissolves. Because that's, I believe that's just isopropanol as a solvent. I use this in a dispensing bottle with a really fine needle. The needle is chosen purely so when it falls over it doesn't really dribble out. Right, I'm going to put a finger over there and try not to stab myself. That would be bad news. And I'm going to give this a shake off camera while we look at other things. So this makes me think back to when I got a bit of soldering equipment from China. And one of the things it came with, is this doing anything? Yeah, it's going clear, so it is dissolving. Okay. One of the things it came with was this little cardboard carton with a solid flux. And I thought, what am I supposed to do with that? I didn't realise that this really is just basically pine resin. And the place smells. It smells like Christmas, quite frankly. But that's the same as this. This came from the Polish cellar, and it's basically poured some of the melted resin into a little tin and then put a lid in it. And I see other people using that, literally scooping up the soda and then applying it to a joint to actually flow the soda. Interesting stuff, though. Another thing that came from eBay, I'll get to the other components after, was this from one of the Chinese warehouses. Let's crack that off. It's disintegrated into dust. Lovely. This is LED rope light, and it's got about 36 LEDs a meter, and this operates directly at 240 volts. So you've got the plug leading to a potted, well, I say injection molded rectifier, leading up to the end cap, where maybe I should actually try this out before taken apart. So it's got this little thing, very traditional style. Is that keyed to stop me connect it the wrong way around? Or have I just screwed up? Is there a... No, it's not keyed. So I might just blow all these LEDs now because I don't 100% know the correct polarity. Excellent. Okay, we'll find out when I plug it in. Let's plug it in and see if it blows all the LEDs. Let's zoom back out again because I've probably been off shot for most of that. No, that was the correct polarity. So this thing converts the AC to DC. It then feeds these bus bars that run along this rope. And there's an inner plastic core and an outer plastic core. And at each end of a string of LEDs and resistors inside, there are 10 1K resistors and there's 36 LEDs as a sort of loose wired circuit. They're pressed into little holes in a core. Then they're tapped across the two bus bars, and then they basically just tap across one other side, and it runs them in series across the mains. And you can cut this every meter and then just put an end cap where you want it. But if you do the maths, hold on. There's 36 LEDs. It's around about 240 volt RMS. Let's see what voltage. I measured this. It was roughly 16 milliamps per meter, and there's roughly 10 1K resistors dissipating pretty much quarter of a watt each. Let's do the sums here. So the voltage across the resistors equals the current 0.016, that's 16 milliamps, times the total value of the resistor, which is 10,000 ohms. So of the 240 RMS, about 160 is being dropped across the resistors. So minus, say, it's 240 RMS, 80 volts being dropped across the LEDs, divided by the 36. They're a mixture of red, green, yellow and blue. So half of them will be about 3 volts, half of them will be about 2 volts. It works out on average roughly about 2.2 volts per LED. So by far the most of the power being dissipated in each meter is in the resistors. But that's interesting. We'll take a look at that later on. It deserves its own video. This came from CPC. I'm a bit perplexed about this. It's a dusk sensor. Oh, I wonder why they had the plastic bag there. It says cover for automatic photo control switch. So this is for testing. You put a black bag over it. This looks just like the ones you get from eBay. There's a metal bracket. And I'm guessing that this basically, you slot it under this and then you screw this to the wall, but then it's bare wires, it's single insulated wires. So you can't screw this to a wall without some form of containment over these wires. And you can't put it inside a light fitting because then it would be affected by the light in the vicinity from the light. The only place I could really see this working is in a dome, an outer dome on top of a light fitting. It's like the classic Chinesey ones that I'm just looking to see if I've got one nearby here. I saw one recently, but it's not going to be on hand when I look for it. It makes me think of the Chinesey ones that I'm guessing the Chinese are quite happy to just basically stick this up on a wall and just have the bare wires going into pudding joints or junction boxes. But I'm not really sure why CPC are selling one like this, because I'm not sure where you'd actually be able to use it that exposed single insulated conductors would be acceptable. It would need to be shielded from touch inside an enclosure in some way where it would have to be a clear enclosure to let the light through. Very strange. Odd. We shall explore this in another video. This is just a sort of rough video showing stuff. Next, I've been appearing in a few live streams with HVAC Overtime and potentially some other channels. And one of the things I want to do is improve the setup for that. So I kind of like streaming from the phone because the modern phones are fast and efficient. It's designed well for the task. So I've looked at other splitters that let me connect to the standard 4-pin port on the phone and connect my usual microphone and just get some of that flux off and the headphones at the same time for use when streaming. But I couldn't find a connector that I thought was suitable quality, so I got some random 4-pin plugs and then some 4-pin and 3-pin sockets to actually cobble something together with a short length of standard audio cable, which is it's got 2 core which can be stripped apart, red and white core with outer screen wires. So I'll be making up a custom audio adapter for that application. The next thing, switches, rocker switches. You don't see this, but above here, above the bench, is a little junction box with a rocker switch on the side that I can use to turn the light on and off. But there's also a passive infrared detector here. So when I walk up to my bench, it turns the light on. And if I walk away, because I tend to get distracted, if I walk away too long, it turns the lights off. And that was purely initially because when I'm distracted, I didn't want to leave the LED lights just running all the time. It lets them get a chance to cool down because they're sort of highish power, well, not that high power, 20 watts each lights. And I thought that, that's a good idea to let them cool when I'm not there. So I got a couple of these switches. One was, there were 2 similar looking switches. I wondered what the quality is. The only way to find out the quality is to open them up. Then they kind of won't go back together again properly. But I'm going to build another box through in my other sort of recording, the other bench area where I've got much higher height to the bench. I'll turn this solder iron off now. Next thing, a solder iron stand, because I fancy cracking out the old Antex again and giving it another go. The Antex was my solder iron of choice for decades, about 25 years probably. So this is a solder iron stand that takes the standard little brass wool ball. These work very well. Very good for wiping the solder. When you take these out after a while, the solder's wiped off and formed little balls that have drizzled through it. So it's full of little granules of solder at the bottom. But this is a fairly heavy stand. Where is my Antex? Hold on. The Antex, complete with a convenient bit of solder wrapped around it. It fits. That's not bad. So this is a thermally balanced iron. And the reason I stopped using the Antex is because I could only get the bits in a selection pack of 3 at the time. And I tend to use a 3mm tip. And all you could get was 1 3mm tip and then 2 that you wouldn't use. So I stopped it because that was just a really expensive way. It was cheaper just to buy a new solder iron, basically. But I got a new a bit. Also, rather annoyingly with the Antex, the bits used to last absolutely ages. And my solder iron, literally, I had a switch when I went into my workshop, and I'd turn it on and the lights would go on and the solder arm would go on, and you know, there were times that I've left it on accidentally. There was time I went away for actually I was working away for about a month, came back and found the solder arm was still on because I'd turned the light off, unplugged it separately from the usual arrangement and just didn't realise it was on. But the tips would last for absolutely ages. But they went through a bad spell that they just failed. You know, literally the tips just eroded away in a matter of days, and it just kind of put me off the Antex for a while. I think it needs revisited, but it's still a very expensive iron for what it is. But that looks a decent, strong base. How's that going to go for this? That could be useful for that as well, although the fact that it's got the metal tube in it and it touches it means it's going to take a bit of the heat away. It's got a metal tube in here. Not sure that's the best approach. I may keep the other solder iron stand for that one. What else? Oh yes, one thing I added to the order that I thought was quite interesting, I'll turn the bench power supply on for this, was this LED designed for the automotive industry. It's literally designed for mechanics to change in situ. So this is a yellow LED, and it's got an outer ring with metal fins, spring-loaded metal fins, and then it's got a screw thread in the back. And if I turn my bench power supply down, let's not have it at 12 volt, that would be quite dramatic. Let's put it down really low. And I shall clip I think the outer is the negative. And the thread is the positive. And I shall gradually creep the voltage up until I see the current going up. If I've got the polarity right here, oh, there it goes. So this one is a yellow one. Not sure what it's rated at current-wise, but it's bright. That's it running about. That's it running at about 470 milliamps. But the idea of these LEDs, is that if you have them in a vehicle on a circuit board and the LEDs individually fail, all you need to do is use a nut spinner to actually take the nut off the back, put a new LED in, and put it on. I think these have been around for a while. I wonder if they ever took off in many applications. It strikes me it would be quite useful for trains or trucks. But the downside there is that if water gets in, it's not the LED you have to worry about, it's the printed circuit board tracks. Other things, cable glands. Standard 20mm cable glands. The 20mm is the hole that you cut to put them in, and then it can accommodate the cable from 6 to 12mm as you tighten it up, and provides a watertight seal, but also just grips the cable quite securely. And that is more or less it. And some regulators, 7805 regulators. I've got some of these somewhere, but I've buried them. It was easier and cheaper just to buy more because they're always something that's quite useful. And that's more or less it. That's what's on the bench right now, and I'm going to tidy it off. I could show you other stuff. Hold on. I do have other stuff. As part of the Christmas light, I'll be getting sections of this fake neon, this LED neon. And the quality is kind of variable, but interesting colours. Let me hook this up. This one's going to be 12 volt. Let's see if I can get this polarity around the right way. This one is a sort of purple LEDs, but it's a little hint of phosphor over. I'm guessing it's a little smidge of red phosphor. Let's see if I can get this to light up now. Yes, it is making connection. Oh, that's decent enough. So this is a purple, and it's not a bad colour actually. You can see, I can't see what you're seeing on the camera, the dots at each section where it bridges between the LEDs. It's a very clean linear line to me. I've just popped the wires off, not to worry. Light coming back. But I've got a good selection of colours, green, pink, purple, blue, red. This stuff is just ridiculously cheap, almost too cheap these days. I wonder if this is crap stuff or if it's decent. I don't know. I'll soon find out. I'm not going to run it at its full current. This one was supposed to be cold white, but it's actually warm white. But there we go. That's more or less what's on my bench. Now I've got a reason. Now I can actually get the stuff off it and start making videos again. So I just thought that would make an interesting sort of mailbag type of video, but really kind of showing the sort of the mail that I actually get sort of through when I've been ordering electronic components. So I just thought it would make an interesting change. Hold on. Has this dissolved? It's continuing to dissolve. That is getting darker. So the rosin is actually melting into the isopropanol by the look of it. So that flux has just got more potent. How useful.